So like I was saying, for this problem, there's no way that I can break the denominator. We could sit there and we can go through and try to find those zeros. You'll find that they are imaginary, but they're not useful in the real world, or you're not going to get any real asymptotes there. So there's no vertical asymptotes. Does this thing have any horizontal asymptotes? It does? It does? Where? At y equals 0. How do you know? Because the top degree is less than the bottom degree, then that means that the line y equals x equals is going to be an asymptote. Okay? So the way that it works, it might kind of come through or bounce or cross one time. Not sure what that looks like. We need more information. Maybe I can throw it into my graphing calculator and figure that out. Now, what if this did not read that? What if it read 3x squared plus 25 over x squared plus 25? Could I still have vertical asymptotes? Actually, let me change this a little bit more. Let's make this a minus instead of a plus, because I want to make it a little bit more interesting. Okay? So we have this thing now. Understand the bottom's not plus anymore. Do I have vertical asymptotes? Well, in this case, I'm going to ask algebra, hey algebra, when does x squared minus 25 give me a 0? Because when that is true, then that means that I'm going to have some asymptotes there. So I can go ahead and solve this guy. And then I'm going to take the square root of a square, which means that my solution should now have plus minus 5. So do I have vertical asymptotes? Yes. How many? I have 2 of them. One at positive 5. And I have one at negative 5. Now, how do I know that these are asymptotes and not just removable discontinuities? I wasn't able to cancel any out, and I'm throwing air quotes out here for the recording because they can't see us. But yeah, we can't cancel anything out, so there's no way to eliminate one of those zeros in the bottom. Now, do I have a horizontal asymptote in this case? Yeah. I do? How? The top degree is the same as the bottom one. Very nice. So, fantastic. So, let me repeat that, ladies and gent. Or just you. Because the top degree in the first scenario was less than the bottom one, then that just makes y equals 0 the asymptote, right? Horizontal, I mean. In this case, the degrees are the same. So what we need to do is take a ratio of the leading coefficients, and in this case it's 3 over 1, making my horizontal asymptote at 3. X equals 3? Y equals 3. 1, 2, 3. So there I have another asymptote, half. Okay? So, one thing that, once you get into the higher maths, you're going to see there's going to be a couple of patterns that always take place here. And here's what would happen. You might get, remember that y over x thing, where it kind of did this business? So it might do that, and then it'll come back here, and then it'll go like this, and then it'll come back over that way and finish off like that. So it'll look like this. Might look like that. The other scenario is that it might look like this business here. Okay? Any ideas on what dictates that? Oh, A, right? Happy or sad? Is it standing up or is it flipped upside down? Cool beans. Sometimes you do get some weird scenarios where they do actually cross, and then the other piece would end up, if it goes there, yeah, then it would just come down from here. But we'll get to learn that later on, if it's not beyond our course here. So we left off on our arrow notation. Where are we at here? We talked about the asymptotes. We did that already. We did all that. We did all that. Jesus, were we done? No. Jesus Cristo. Oh, symmetries, right? Did we do symmetries? No. Okay, so strategy for graphing them. there's not really a strategy there. So I don't know what that's supposed to be about. I don't think I have anything in there.
I feel like everything's peeled.
The strategy.
Okay, there's no strategies. You're on your own. Take tea tables. This should be something you guys remember from before, right? To check for symmetries. If you put a negative x in there, and you get out a regular x, then you have y-axis symmetry. If you put a negative x and the whole function changes, then you have symmetry about the origin. You guys remember that business?
Oh yeah.
Right? And then so. Do you say anything more about symmetries?
How do you find them?
You plug in negative x's. So if you have a function, and you plug in the negative x and you get back the same function, then you have y symmetry. When you have a function and you plug in the negative x and the whole function changes signs, then you have origin symmetry.
What about the no symmetry thing?
That means that some changed and some did not change.
Okay, I remember
Okay?
that.
Cool.
It slips me on mine.
It happens to us. That's a lot of rules. Alrighty. Let's see what else we got here. Find the y-intercept if there is one by evaluating f of 0.
I thought we did F1 equals X.
That is interesting. Where are my slides? Where are my slides?
Reboot it. Turn it off and turn it back on again.
No, I don't think it's a problem with that. Oh, these are the strategies. My bad. I remember what I did. It was one big page, like with all these strategies. I was like, no, I think that if I hit people with it, it's going to be too much. So I made a bunch of different slides. So here are the strategies. So the first strategy is determine whether you have that y symmetry or that origin symmetry. Okay? So either one of those. Then you're going to want to check if there's any y-intercepts. That's pretty easy, right? How do you find a y-intercept?
Make Y equals 0. Make X equals 0.
You make x 0. If you want
That's what I meant.
y-intercepts, you make x 0. You want x-intercepts, you make y 0. And then at this point, we're going to find x-intercepts by making y 0. First thing you're really going to do is check that bottom piece, right? Because that bottom piece is going to tell me whether there's going to be asymptotes or not. But also if there's going to be any intercepts. That means that you actually cross that asymptote or not. Okay? Vertical asymptotes.
Wait,
Horizontal asymptotes. What's up?
Wait, go back. What?
Checking for vertical asymptotes. Remember, it's P of x over Q of x. You're going to check if Q of x has any zeros in it.
Okay.
And then we're going to check for horizontal asymptotes. And how many different rules are there? 5. How many rules for horizontal asymptotes?
3.
There's 3 rules, right? And then let's see if I can do something like this. We'll go a x to the nth over b x to the m. Blah, 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 blah. So, if the numerator degree is less than the denominator degree, then what's my rule?
Well, it's like a straight line or something.
The x-axis is my asymptote, right? AKA y equals 0. For number 2, if n equals m, then what's the rule for that? Ratio a over b. What if n is greater than m? No horizontal. No horizon. No horizontals. Okay? Yeah, so just a heads up on that third rule, even though that's not true, you might have an oblique asymptote. And we'll talk about the specific rule for that. Thanks for having your guys' laptops closed and taking these notes. Yeah, you can write it down too. That sounds good. Now you gotta do it twice.
Wait, what does that say, number 2?
So for number 2, you want to do the ratio of a to b. So if these are the same, then you're just going to take a and divide by b. Kind of like what we did in that example where it was 3 and there was nothing there. I said, oh, that's 3 over 1. So my horizontal asymptote was at 3. And that could be a fraction, guys, just an FYI. Because the denominator could also have a leading coefficient that's not 1. That's not 1. So you might end up with something like 3 halves or funky like, 2/3. It is what it is, and that's where it's going to be. Okay. Like 2 halves or something. What's up? I'm sorry. I was making a stupid math joke. Yeah, it's supposed to be an f of x. It's just my function there. I could have done a better job. There you go. Yeah, like 3/3, right? Yes.
What's the word before A?
It says ratio, but it should be ratio.
I thought it was rally.
Hey, I teach math, not English. No. Did I tell you guys I sent an email to some of my colleagues? I told you guys that?
Yeah, she like sent it back.
I'm like, dude, I swear to God, I still don't see the mistakes I made. Oxford, comma. I'm gonna ask her too. What was wrong? Well, I can't say it was a guy because we have no guy English teachers, but I'm not gonna put anybody on blast.
There's probably just
It was funny because we were at a meeting yesterday too, and they're talking about like we're talking about creating missions and visions for our departments, which is a great thing, right? But then someone says, "Man, are you sure you want English teachers to do it? Because they're gonna fight over every word." No, why are we choosing this word? What does it mean? Does it really apply in this context? I'm like, whoa. Waterfalls. So here's the next rule that you want to take a look at. You want to plot some points. So usually what happens, kind of like what we did at the beginning, right? I found some asymptotes. The next thing you're going to want to do, that's awesome, huh? You're going to just want to plot some points. So, hey, you know what? Where does my function exist if x was 0, 0? Is it true? Because if it's not here, it might end up there, which tells me that it's probably going to do that. And if it is down here, then it's probably going to tell me that it's going to do something like this. Does that make sense? You just kind of want to get an idea of where things are going to be at. And of course, we can graph them so we can get a bunch of other points and make it easier for ourselves. But this is what it's saying. Hey, pick some point between all the regions here. See if there's pieces over here, pieces over there. Where are the pieces of my function? Okay. And then 7. I'm sorry, I'm getting excited here.
Maybe more than a little bit. Maybe a lot.
I don't think I understand that.
So everyone understand that next part here on step 6 is just pick a bunch of points, see where the graph exists. So let's say we did have a function. Let's go back to, what did we have?
X squared.
Where were we at? It's way here. So, x, y. So if I pick x to be 0, I would get 5 here, and I would get 25 there. So this would be 1/5. Remember that whole thing? That's what we're doing. But you want to pick your x's so that they're in those regions. For example, remember I said asymptote at 5 and -5? Am I going to pick x to be 5 or -5? No, because I'm going to get something stupid. It doesn't make sense. So just pick something that's between there, and then you'll figure out where it's going to end up at. But definitely between these asymptotes. Not necessarily those asymptotes, because you put x's in, it spits out y's. Okay? Okay. Do you want to do it? Do I want to do it? It went from a question to a statement. So, waterfalls. Raul. So I'm going to do this for you. Do me a favor, put your pencils down and watch me do it, and then I'll let you copy to your heart's content, or take pictures like my paparazzi. So as I'm looking at this, let's see here. Do I have a y-intercept? That's step 1, right? Because it's easy. You make x 0, correct? So if I make x 0, this is gone, This is gone, and I'm going to get 3/2. Right? Am I right or am I wrong? I'm just checking because I make mistakes. Did you know that? Me know Jesus. So 1.5. So I got a y-intercept. I'll use another color. I got a y-intercept here. X-intercepts. Can I really check for any? Could I check for x-intercepts? How do I check for x-intercepts? I make y 0, correct? So let's see here. 0 equals 3x. Sorry, why did I do that? I don't know. 3x minus 3 over x minus 2. What's kind of cool about this is that you only really care. Thank you. What's really cool about this is you only really care about the numerator for x-intercepts. Because if you were going to do that, the way to get rid of the denominator is to multiply both sides by the same thing, correct? And if you multiply by 0, what happens? Gone. So I really care about what's going on here. So x-intercepts, I'm going to worry about the numerator. I got 3x minus 3 is equal to 0. 3x is equal to 3. So I looks like I have an x-intercept over at 1. So I'm going to put that right here. Yeah. Are we good? So we have our x-intercept. What's my next step? Asymptotes? Sounds good to me. Where do I have an asymptote? Over at 2, don't I? So I got a vertical asymptote here. Do I have a horizontal asymptote? Where? At 3. These are the same degree, so I'm going to take the leading coefficient ratio. 1, 2, 3. So there's my other one. And I can kind of already see. Now remember what I was saying, when one goes in one direction, it's going to pop up in the vertical side. Okay? So here's what I'm thinking it's going to do. It's going to go like this. And then this is going to come from over here, like this. But I don't want you just to take my word for it. We should be checking other points, right? So, do I really want to see what it looks like over here? Am I going to check for 0, 0? No, that'll make sense. 2, 2. Let's check 3. So if I put a 3 in there, 3 times 3 is 9. 9 minus 3 is, so I've got 6 up there. 3 minus 2, 1. So this is 6, correct? 1, 2, 3, 4, 5, 6. So yeah, it should be way up there. See that? It just kind of follows that pattern.
Still work.
What?
Still work. It's good.
Yeah.
So that's it.
Good. Oh,
So that's the answer.
I think that's what he's trying to say. No, that's not the answer.
What's the answer?
What did I answer?
I don't know. What did you try?
No, I didn't. We just graphed it.
How do I plug that into math?
You don't.
That's rough.
I hate when math was like, I'm sorry, I couldn't understand this. I know.
Me
like,
neither.
That's why I asked you.
Or no, I meant math lab. Thing, the answers. How do I Yeah.
Yeah, we know what you meant. Questions on this problem?
Can you do that?
Sharif? Huh? Welcome back. We're good? All right, let's see what else we got. Oh, yeah.
What just happened? Wait.
I want to go
Squared.
Yeah, we're not done. So, remember I said to find the horizontal asymptotes, there's 3 scenarios, correct? When the numerator is smaller than the denominator, and then that would give us y equals 0. When they're the same, we would get a ratio A to B. And I said whenever n was bigger than m, there's no horizontal, but there might be oblique asymptotes or slant asymptotes. So let's talk about slant asymptotes. So let me take you back to rule number 3. N is bigger than m. Whenever n,
which one's that?
numerator and the other one. Whenever the numerator is bigger than the bottom by exactly 1.
It's not.
It has to be greater by just 1 degree. Then you get a slant asymptote.
It's bigger by 3.
It's bigger.
If it's bigger than more than 1, then there is none. You don't have to worry about it.
So we don't have
That's why I said, when n is bigger than m by 1 degree, you will have a slant asymptote.
By degree, do you mean number?
Yes. when the degree of the numerator is exactly 1 higher than the degree of the denominator, you will not have a horizontal asymptote. You will have a slant asymptote.
So are we talking about the coefficient or the exponent?
Listen, fam, you need to
Exponent.
Okay.
When the degree, it would be a slant asymptote. So, thank you. Shh. So in this case, no. I'm giving you an example for his sake. Where the degree of the numerator is 1 higher than the bottom one, you will have slant asymptotes. And I will show you how to find those. It's not 3 over 2. It's not 3 over 2.
Yeah, change the bottom to a 4.
Because there's more stuff here going on. So,
You just change like the bottom coefficient to like a 4 just for me.
why?
Because it makes more
Because
sense.
he's still confused on it increasing
I keep
by
thinking
one.
of coefficient.
It's just gonna be y equals
No,
0.
because that's no slant asymptote.
No.
No,
No, what type of asymptote would this be? Horizontal at 0.
Wait, what?
When the top one is greater than the bottom, when the bottom one is greater than the top one, then it's y equals 0.
That's also surprising.
Evan, these are not the degrees.
I
These are the leading coefficients.
Yeah, I got that.
All right, cool. So, another question. Go ahead.
Okay, if it's 3x squared over 5x, does that still count?
No, because. Oh, hold on. Did you say 3x squared?
Yeah, 3x squared over 5x.
Question: is the numerator degree 1 higher than the denominator? Yes. So yes, it does count.
Okay.
As long as the numerator is exactly 1 degree. Waterfalls! Listen to my voice. When the degree of the numerator,
It's 1 higher.
I'm gonna wait. When the degree of the numerator is exactly 1 degree higher than the denominators, you will have a slant asymptote. Okay? It doesn't matter if it's a 2 with a 1, a 1 with a none. It's still 1 degree. It follows the rule. Okay? So, the way you find that, is going to be by dividing. And you probably can't use synthetic division. So when you divide the two, the quotient will be the equation of that line. Let me tell you what I mean. Oh my, look at that.
That's scary.
The degree here happens to be exactly 1 higher
Wait.
than the denominators.
This has to
But you still also have the horizontal asymptote.
So let's break this down real quick here. Thank you. Do I have a y-intercept here? Yes, where's it at? Negative 3.5? If you make x 0, that's gone, that's gone, that's gone. Right? So negative 3 over 2. 1, 2, 3. So here is my,
Where are you getting 3 over 2? That's 7 over 2.
7 halves.
what's 7 halves?
7 halves.
7 halves.
It's 7 over 2.
Isn't it 3.5?
Yeah.
3.5.
And what did I say?
3 over 5.
You said 3 halves. It's 3 and 1 half.
3 and 1.
No. Well, you're right. It is 3 and a half because that's my decimal point now. You're correct. Not 3 halves. Thank you for correcting me. So here's my y-intercept. I think we were all saying the same thing, but I was saying it wrong. So there's my y-intercept. Do I have any x-intercepts? What am I looking at for x-intercepts? The numerator, correct? 2x squared minus 5x plus 7. Is that thing factorable?
No, let me check. 2.
Oh, who has a factor machine?
Yeah.
Oh yeah, it's factorable.
It's not factorable.
It's definitely factorable. We have a math class right now.
It's
I'm
factorable.
saying it's factorable.
I
Like
just
2x is plus 2x minus x minus 7.
Yeah, here we go. This would have to be minus and plus,
No.
right?
Yes.
Yeah, there you go.
Yeah, it has to be
Oh,
negative
but that's
negative.
not going to work then.
Yeah, because it's a plus.
Ah, it's not factorable. It's not factorable, right? One more time, please.
From using the discriminant, I did not get something that was factorable.
Right. So we needed this to be a negative. Oh well. No what? No x-intercept. So anyways, do we have any horizontal asymptotes? No, but we might have oblique. So here's the way you do it. Now, I'm going to take back what I said a second ago. Because this is a first degree binomial, then I could use my synthetic division, couldn't I? Okay, that's the only time I can use it. So what makes my denominator 0? 2. And then I'm going to get 2, negative 5, 7. I've got 2. 2 times 2 is 4. That's going to give me a negative 1. That's going to give me 2. Negative, so I get 5. So this is going to become my equation of that line. So this becomes y equals 2x minus 1. That's my remainder. You can throw that out. Right? No, not really. That's the equation of the line right there. So negative 1, then I'm going to go up 2 over 1. Up 2 over 1. So that would be my oblique.
You said we couldn't use synthetic division.
I did say that, and I said I'm going to take that back because there's one scenario in which we can use synthetic division, and that's when we're dividing by a first degree binomial. Okay? If this was any higher, we couldn't do that anymore.
Wait, I have a question.
What's up, boss?
On the x-intercept, why would it be x equals 2?
What we factored out? Because we tried to factor it out, right? Can I get rid of this, guys?
Yeah,
This is just division, right?
I actually did it.
All right, so we tried to factor it. 2x squared minus 5x plus 7. 2x, x would work for this.
But you have to do that on the numerator, not on the denominator.
Yeah, because here, think about this real quick. If we were going to do, if we want to find a y-intercept, we make x 0, correct? And that was pretty easy because all these x's go away. To find our x-intercepts, we make y 0. So if we make this 0, then we're going to get 2x squared minus 5x plus 7 over my denominator of x minus 2, correct? The way that I get rid of it so I can solve it, I have to multiply both sides by x minus 2, don't I? And here I would get 1, so I get that. But what happens when I multiply by 0 on this end? It all just goes away. So save yourself the time of doing this process and just say, whatever makes this 0 will be my intercepts. That makes sense? That was a good question. I think that's all I have.
Wait, so what is the dot down there for?
That was our y-intercept. So that means, now I'm kind of disappointed because I thought we were going to get an asymptote somewhere else. Wait a minute. No, there is a vertical asymptote at 2.
Yeah, that's what I was saying.
1, 2. So that means that this bad boy is probably going to do something like this, and then over here like that.
So it's not, you called it.
Yeah, that's oblique. But we have one vertical asymptote for this denominator. I'm not even sure how we missed that.
Wait, yeah, that's what I was saying.
Okay, my bad. Yeah, I don't even know how we missed that. Thank you. One at a time.
Never mind.
One question at a
Yeah,
time.
maybe raise your hand.
Go ahead.
I'm still confused how you got the oblique asymptote.
I just divided. I divided the numerator by the denominator.
Oh, okay.
And then the quotient becomes the equation of the line. Let me clear my throat.
I have a higher grade than you.
Wait, so on the
I have 100%.
x-intercept, do you use the denominator?
On the x-intercept? No, the x-intercept should just do the numerator. There's a difference between x-intercept and vertical asymptote. Yeah, so be careful there. I see where you're going with that. I want to make sure we're good here. Yeah, and I really don't know how we just completely forgot to check for vertical asymptotes. What's up?
Okay, so you can have a graph, which is the oblique,
Uh-huh.
but then you can also have those little.
So, let me.
Math.
If you have. No, that has to be true. You cannot have horizontals and obliques because of the rules, the way they work.
Oh yeah, because
Okay.
it's not gonna. I get it.
Okay? So in this case, I don't know how I just totally missed my horizontal asymptote over at 2. 1, 2. So we have that bad boy. Okay? And then based off of the rules, I see that the numerator is exactly 1 bigger than the denominator. Then I want to do my division. And then the remainder ends up being the equation of that line. So,
You mean the quotient?
sorry, thank you, the quotient. The remainder gets thrown out completely. The remainder gets thrown away completely. So we can do our synthetic division only in this case because we have a first degree binomial we can divide by. We have 2, and then we have 2, negative 5, 7. What do we end up with? 2, 4, negative 1. And I don't even have to finish this at this point because all I really care about is this. This is going to be y equals 2x minus 1. That is the equation to the oblique asymptote. So I graph that bad boy. Negative 1, and I'm going to go up 1, 2 to the right 1. So it looks like that. Now, since we already had a y-intercept of negative 3 halves, 1, 2, 3, and a half, we know it's going to have to be down here, and the other piece would have to be up there. Let me sketch that. Let me throw that into our calculator. Saxophone. Thank you. Your time for a second. You have graphing calculators. You really want to use them. They're a really good tool for you to check what you're doing as you're working. Make sure that you're doing it correctly. And if you find that something is not correct, then you can go back and check your work. Also, you do not want to become dependent on it because you need to know where these numbers come from. Sometimes they ask you the weird questions, right? Like, hey, why does this function look like this? And you're like, I don't know, because the calculator told me. And guess what, you fools? You're wrong. You just lost points. So, let's do that real quick. Now, thank you. You really want to take a look so you can see how to do this, unless you're already a master of the calculator use. Give me my stank eye. Alpha F1 will let you put a fraction in there, and that way you can have that numerator denominator business going on, okay? So what was our top function? 2x squared?
Yeah, minus 5x plus 7.
Minus 5x plus 7?
Yeah.
And then in the denom, it was x minus deuce. Okay, so there's my function. Let's graph that real quick. It might look weird because I don't have the correct setting. But look, there it is. Bye-ah! And there's the other piece like I told you. It's not going to draw my asymptotes because the calculator doesn't know that they're there. But it does know that when it gets here, there's an error. And when it gets close to our line over here, there's another error. But you might want to take a look at that, see what it looks like. Okay? Pretty cool, huh? It's cute. Huh? Oh yeah, that's a great idea. So let's go y equals. Isaac, that was brilliant, bro. Britta says graph the asymptote. 2x. Who said it? MJ. Oh, that's low, dude. He didn't even give you your props. Good job, MJ. So let's go graph now. So we should have first the.
You didn't even put one, Mr. Munoz.
What did I do?
Yeah, you didn't say the one.
Oh, I got excited. Sorry. So here's our first function. It's gonna come through. Boop. And then we have that. Boop. And then check it out. 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 Check it out.
That was last.
Oh.
That was a close call.
I know there's there's a way to fake
Yeah.
to fake a horizontal asymptote. I don't remember how to do it, but it's not equal to it, but it's so close. Let me see here. Yeah, you gotta go like really, really high. Anybody know how? Or should I Google it real quick?
Google it.
How to when someone sings a joke.
Yo, what up? Dash, dash, toes. Thank you. Muchas gracias. So I'm not going to spend all that time looking for it right now because I don't want to forget to put the homework. But if you have an older TI-84, like 83 maybe even, and you plug that in, they were not that smart. So the calculator, seriously, the calculator would go and it would graph this, and it would go to here, and because it kind of went on to infinity, and it knew how to go up there, it would actually draw a line that says, from somewhere over here, ends up there, and it would just have this weird broken line that went all the way to the top, and then it continued here. So if you can find someone that has an older one, plug that in, and they might still draw those horizontal asymptotes, but these newer ones don't. But I know there's a way, and I can't find it. But I am done for today. I'm going to put up the homework, and you guys can work on that.